Recently, the IoT has been reaching further into our lives. To use the IoT, devices need to communicate via wireless connections. Various low-speed and wide-area wireless standards used in IoT are collectively referred to as LPWA. This table summarizes the main specifications for LPWA. LPWA mainly uses frequency bands below 1 GHz and has a range of several kilometers. However, its maximum transmission rate is low. Even with the fastest Wi-SUN, the maximum transmission rate at the physical layer is 300 kbps. This is fast enough for sending sensor data, but too slow for video transmission, which will be demanded in the future. This is why IEEE 802.11ah, or simply 11ah, is attracting attention. The maximum transmission rate of this standard is 20 Mbps when only one antenna is used. This transmission rate comes close to that of Wi-Fi. Since it is IP-based, it makes device procurement easy. However, to enable 11ah to realize its potential, you need to pay attention to its usage conditions, such as the impacts of terrain and shielding objects, interference with other radio systems, channel selections, regulatory restrictions on wireless transmission, and power-saving operation. Without optimal design considering each of these conditions, stable communication is not possible, leading to communication interruptions. To solve this problem, NTT Laboratories have been studying 11ah and developed the world's first control engine for 11ah. When this system is started, access points begin to communicate with devices and collect information about the communications environment. The control engine analyzes this information and selects optimal operation parameters from 3 perspectives: stable wireless communication, automated transmission management, and expansion of communication areas. Control commands are used to set these parameters to the access points and devices. In this way, the network operation optimal for the particular environment is set up automatically. To develop this system, we conducted the following experiment. We installed an access point on the roof of the Yokosuka R&D Center. A video was transmitted from that position at a rate of 300 kbps. We used actual devices to examine how far the video could be transmitted without any reception problems. We found that 11ah can transmit video effectively over a significant range. We developed a prototype application system. A solar panel and a battery were installed so that the system can be used where no power supply is available. We predicted the power output of the solar panel from the weather forecast and ran the system automatically, paying careful attention to the remaining battery charge. With this system, you can freely install sensors and cameras in the service area for various purposes, such as the monitoring of rivers and forests, the prevention of wild animal damage to crops, the security of factories and offices, the monitoring of agriculture and fisheries, and oversight of infrastructure. By installing many sensors and cameras over a wide area, you can replace visual inspection-based work with IoT technology. Also, in the event of a disaster, 11AH can be used to set up a temporary wireless network or to monitor damage using drones. This system dramatically broadens the potential applications of the IoT.